Okay, so the next question that we have here is if each of the observations observations x1, x2, x3 all the way up to x of n is increased by a, where a is a negative or positive number, show that the variance remains unchanged. Show that the variance remains unchanged. Okay, so in order to solve this problem, so then you can say that as a solution, so basically if each of these observations is increased by a, or where a is a negative or positive number, then we want to show that the variance remains unchanged, meaning that basically variance is nothing but sigma squared, which is equal to 1 over n times sigma of x of I minus x bar whole squared as I goes from 1 to n. So now now suppose that each of these numbers is increased by a, meaning that the new series becomes x1 plus a, x2 plus a, x3 plus a, all the way up to x of n plus a. So n doesn't change here, of course. N does not change because that's the sigma f of I does not change here. And the only thing that changes is x of I and x bar. So your x of I is going to be basically a plus x of I. The new x of I becomes a plus x of I. And your x bar becomes your x bar. If you want to calculate it, that would be basically the new x bar would be sigma x of I divided by sigma x of I divided by by sigma f of I. So now sigma basically, and of course it's easier to write this in a more systematic way, because this way I can see that I'm basically confusing myself, right? So what I can do is that I can say that let x be the mean of x1, x2. So let me write it from the very beginning. Let it write it properly. So I can say that let x bar be the mean of basically x1 plus x1, x2, x3 all the way up to x of n. Then the variance is given by, then the variance is given by the variance of basically those numbers is given by sigma of 1, for example, squared is equal to 1 over n times sigma of x of I minus x bar whole squared as I goes from 1 to n. Now, if A is added to each observation, if A is added to each observation, the new observations will be basically y of I, which is equal to x of I plus a. So I call this, for example, equation number 1. Now, let the mean of the new observations be y bar. So you can see that this way, I can understand what I'm saying, and then I can move in a step-by-step manner in such a way that I don't confuse myself. That's very important. The way that I was solving this problem, I was just confusing myself. Now let the mean of the new observations, the mean of the new observations be y bar. Then y bar is equal to 1 over n times sigma y of I, which is equal to 1 over n times basically sigma x of I plus a, which I can write as 1 over n times sigma x of I plus sigma a, as in both cases as I goes from 1 to n, And you know that sigma of, that's a times n, so sigma x of I as so if I multiply this by these two terms, what I will get is 1 divided by n times sigma of x of I as I goes from 1 to n plus 1 over n times sigma of a as I goes from 1 to n. So you know that sigma x of I divided by n is just simply x bar. And sigma a as I goes from 1 to n is just simply n times a. And then you have divided by n here, so these two will be cancelled out, so that's x bar plus a. And so what that means is that your y bar is equal to x bar plus a. So that means that your y bar is equal to x bar plus a. Call this equation number 2. Thus the variance of the new observations become, now what we have done is that we have calculated basically y of I and y bar in terms of x of I, and then we can now calculate the new variance, the variance of the new observations. So then I can say thus the variance of the new observations would be sigma 2 squared is equal to basically 1 over n times sigma of y of I minus y bar, y of I minus y bar whole squared as I goes from 1 to n. And over here we said that y of I is equal to x of I plus a is equal to 1 over n sigma of y of I is x of I plus a, and minus y bar is equal to x bar minus x bar plus a, which becomes negative x bar negative a. So as I goes from 1 to n, and that means that basically these two will be cancelled out, so that is basically 1 over n sigma of x of I minus x bar, and that there is a whole squared here as well, of course, whole squared as I goes from 1 to n, which is equal to sigma of 1 squared. Thus the variance of the new observations is the same as that of the original observations. And there is a note here, and you saw how I saw that too as well, of course. And you saw that basically if you don't jump into your thoughts, and if you go very slowly step by step, you can always solve the problem very easily. But if you're in a hurry, and if you want to solve the problem, jump from here to there, from here to there in your thoughts, then of course something always goes wrong, and you will of course confuse yourself. That's the worst part. There is a note over here that says we may note that adding or subtracting a positive number or from each observation of a group does not affect the variance. Does not affect the variance because, well, basically your x bar changes and your observations change together, so that doesn't change it. Now question number 19 says that the mean and standard deviation of 100 observations were calculated as 40 and 5.1 respectively by a student who took by mistake 50 instead of 40 for one observation. What are the correct mean and standard deviation? That's also a good question. So we have the mean and standard deviation. So the mean of, let's say your mean, you have the mean and standard deviation sigma of a set of observations of 100 observations, and is equal to 100, were calculated as 40 and 5.1. Now this student who calculated these two values took by mistake 50 instead of 40. There was a observation which was basically 40. It was the actual value was 40. The actual value was 40, and then instead he's taken 50 by mistake. That means that basically now these values calculated are actually calculated with this number 50, but the actual number was 40. So now what we want to do, we want to know what are the correct mean and standard deviation. Okay, so now to solve this problem, basically you know that the number of those observations were 100, and this is your incorrect mean. This is your incorrect mean, and this is your incorrect Standard deviation. Standard deviation. So you know that, and you know that the actual value that the student should have taken was 40 for the particular observation, and instead of 40 he has taken 50. So what you can do is that you know that, well, the value of the value of the incorrect mean, x bar is equal to 40, which is the incorrect mean. Now, since the incorrect mean is equal to 40, that is equal to 1 over n times sigma x of I, as I goes from 1, for example, to 100, because you have 100 observations. And and of course, since you have 100 observations, so instead of n you can write 100. You can write 100. So that means that basically 40 is equal to 100th times the sigma of x of I, as I goes from 1 to 100. So now if I multiply both sides of this equation by 100, I will get 4000 is equal to, basically this becomes a 1, then you'll get sigma x of I, as I goes from 1 to 100. So that means that this is the incorrect sum of observations. This is the incorrect sum of observations. Now the correct sum of observations the correct sum of observations would be basically this, the sum of observation that you have would be equal to 4000, and you have taken this value by mistake, so you have to take that out, and then instead of that, you have taken 50 by mistake, so you have to take that out, and instead of that add 50, add 40 here. So that means that negative 50 plus 40 is equal to negative 10. That means that you have to subtract 10 from 4000, which is 3990. 3990. So the correct sum of observations is 3990. And so the correct mean is equal to sigma x of I, the correct one, divided by sigma f of I, which is equal to 3990 divided by sigma f of I, which is equal to 100, which is equal to 399. That is the correct mean. 39.9, I'm sorry. 39.9. 39.9. So that is the correct mean. Now so your standard deviation basically standard deviation is the same thing as I don't know what sort of formula they have used to write this. I don't understand what they have written here. Let's solve it. Let me solve it myself. So the standard deviation is basically, you know that standard deviation the standard deviation is basically nothing but sigma, which is basically, you know, that sigma squared, which is variance, is basically 1 over n times sigma of basically x of I, sigma x of I minus x bar all squared as I goes from 1 to n. So that's basically that is deviance. So if you take the square root of this, that becomes standard deviation. So I can write the square root of 1 over n sigma of basically x of I minus x bar all squared as I goes from 1 to n. So, and the value of and the wrong value, or the incorrect value for the standard deviation, is 5.1. So I can write 5.1 is equal to the square root of 1 over n, which is 1 over 100, times sigma of basically x of I minus x bar, which of course I have to take the incorrect mean, which is 40, and square this as I goes from 1 to 100. Now this is 5.1. This is 5.1. Now what I need to do here okay, so now about the rest of this. Now they have used here some formula for standard deviation that I do not understand. I don't know what they have done here. But I'm going to not basically solve the rest of this example, because I mean frankly I don't know what they've done here, and it's not that important really. So now let's go to the miscellaneous exercise on chapter 15. We have some 7 exercises that we can solve over there, so I'll see you in the next video. Thank you.